Hello everyone. Today I'm going to talk about Search Your Best Available Route, which is an AI-driven app that can optimize your route when you're traveling around cities in terms of cost, time, and carbon emissions. So the problem currently in Malaysia is the increasing dependencies on private vehicles, which people don't really believe about public transport. So this causes carbon emissions and environmental impact. And secondly, because there is this confusion in public transport usage where these multi-destinations is not available when people want to travel to different locations. So people will just tend to drive when they want to visit a lot of locations. The thing is the separated system nature, where this payment is separated and they cannot track the transactions. And also this carbon emissions, no one is focusing on this. So they don't know how much carbon emissions carbon footprints they're actually producing when they're using driving methods. So the impact is, and the government is actually proposing this 2030 carbon emission target. They try to reduce it to 45% per GDP. Secondly, this declining usage in public transport. And the third thing is the navigation experience for both non-commuters and for these tourists. As we are pushing our tourism to Malaysia, and this is very important because for people that are not Malaysians, they come from overseas, they have to know like that is an app that can help them to navigate through cities very well. So our solution is we have this route optimization using Fast API, which implements these network X and OR tools for using, is especially used for graph methods to find best optimized route in terms of cost and time. And secondly, the multi-destination we design, where it changes from traditional way of A to B, where you can put multiple stops for this public transport. And the third thing is the carbon emission payment tracking system. So people can pay and track with our app and also earn carbon credits while traveling in public transport, and also implemented NFC. So this is the brief architecture diagram on what we use. We're using this React Native and Expo Go front end, and we're using a 5-wish gen kit to figure this whole architecture work. And we use RAG to improvise and to improve our AI results. And also we use this Fast API for this backend engine, and also we use this Google Maps API for this location suggestion. Maximum potential market for this whole thing is all the people that are using this public transport and all the budgets that are given by the government and the digital ad market store. We are planning to implement ads within our app. And the second thing is for the reachable market, well, it's for the VM fund, which is Visit Malaysia campaign funds. The short-term market, we can use ads revenue and contract government revenue to get this short-term business market model. So the first thing is the B2B. We can collaborate with companies. We can use Google Ads to advertise in our platform so that we can generate a revenue in short term. And in long term, we can collaborate with Ministry of Transport, Ministry of Governments, and we can sign service contracts where we provide them this service where it's centralized platform for the users to use them and improving the infrastructure. We have multi-stop transport, which this is the most unique thing where other service provider doesn't provide. And we have this AI analysis and integration of payment methods, and also considering cost, time, and carbon emissions where others they don't consider carbon emissions, and also this real-time accurate public transport schedules. Future enhancement, we are planning to add these DRT schedules. It adds the algorithm for driving routes. Also, should include public transport that connects with Singapore. Include these speech-to-text modules for better convenience. So this is our team member, me, Leong Yu Hang, and my another teammate is Daryl. So thank you.
This is our chat screen. Users can enter any prompt or ask any route from starting location to end location, or any optimized routes based on cost, time, or eco-friendly. So here we can enter our prompt, then we can send it. Then we have our cards, rewards, and profiles. So for cards, it's for payments like NFC payments. Then rewards is we can use our saved carbon emission points and convert them into points to redeem any rewards. So for this chat, once we hit the send button, the system will link us to here. So you call chat flow. For example, I take this as an example. We go through this Firebase function, this chat flow. Then we pass intent. We extract the intention of the user, the meaning from the prompt. Then go through the Gemini to understand it. After understanding, then we pass it to here, and it will call which backend function to proceed with the execution. So it will call our Fast API, like Python Fast API backend, like this optimized route. Then we pass in the input and output. Then we determine which route or which type of function to execute. For example, we have format single route, or we got another one is TSP, multiple destination. So our main feature of this app is our multiple destination to optimize multiple destination, and is solving the traveling salesman problem. So here you can see that the output. Then here we will format the output from the Fast API, so that this will provide a human readable and more understandable response to the user and return at the front end. Then returning at the front end, users can view the route map by pressing the view route map button. Then it will show all the carbon emissions, the routes, the time taken, and the cost of the route. Then user can also view the route polyline on the maps. And we also develop our system. Our AI agent is the Firebase Gen-Kit. Then our backend which is Fast API Python with Network X and OR tools from Google. Then front end we are using React Native with Expo. Then here's our RAG data. This RAG will help in providing a context during the pass intent function, which is extracting the intention of the user, and also formatting the output from the Fast API and formatting it and converting it into a more human readable instructions. And here we are using the Google Anti-Gravity IDE. And that's all from me. Thank you.